So friends, in continuation with the previous video of design of a RE wall, you have seen the internal stability. Now let us see the checks for external stability. So first is going to be check for sliding, then overturning, then bearing capacity failure. So all those checks you will have to provide it. Now you have just seen that in the facial panel you have a wall, the reinforcement, and this side is backfill. And the properties of the backfill, let's say it is throughout the surcharge Q on the backfill, and the properties of the backfill is known to you. So now, how to find out the factor of safety against sliding? So you need to find out here the horizontal pressure. This is the wall. So the horizontal pressure due to overburden will be KAB, K of backfill into gamma of backfill into height. So the pH will be the horizontal pressure due to overburden plus horizontal pressure due to surcharge. So this is due to overburden, and plus this is due to surcharge. This will be K due to backfill multiplied by Q. So the pH due to overburden will be half KAB gamma B into H square, half base into height. Height is H. So this total height is H. And this will be plus KAB into Q into height. So there is another force. The resultant of this force will be at H by 3, and the force PHQ will be acting at H by 2. So having known the value of pH, you can find out the factor of safety for sliding very easily. So find out all the values. This will be half KB for 30 degree will be 0.33. Gamma B is already given as 18. It is 18. H is 9 square, 0.33, 34.43 into H, and H is 9 meter. So you can calculate this very easily, and the sliding force is going to be, this will give you 240 0.5 multiplied by 0.33 into 18 into 9 square, 240.57. So this is 240.57 plus this becomes 0.33 multiplied by 34.43 multiplied by 9. This is 102.25. So total pH is going to be, pH due to backfill is going to be 342.82 kilonewton per meter. So that's the kind of force you are going to get it separately. And the factor of safety against sliding, you can find it out now. So what is the total vertical force here at its CG? This is the weight of the reinforced zone multiplied by tan delta will give you the resisting force Fr. So Fr will be Wr into tan delta, and Wr you can easily calculate as gamma r kilonewton per meter cube into this length. This is the length of the reinforcing element multiplied by its height. So very easily you can calculate it and multiply it by tan delta. So substitute all the value. Delta is 38. So tan 38 and we can easily calculate tan 38 multiplied by 9 multiplied by 7 meter multiplied by 22, so kilonewton per meter. This is going to be 1082. So factor of safety therefore against sliding will be Fr divided by pH. So this divided by pH is already known, 342.82. So this is giving you 3 point approximately 16 greater than 1.5. Okay. No problem. It is safe in sliding. Now let's calculate for factor of safety against the another is overturning. As I told you, overturning is very important. Walls should not be overturned, and therefore against overturning, this about this is going to be L by 2. So this is going to create a resisting moment. So Wr into L by 2. So this will be a factor of safety against overturning will be WR into L by 2. And this will try to overturn it. So this will be acting PHO, which is 240.57 and acting at H by 3. So this becomes 3 meter. So into 3. Plus the moment created by PHQ, that is 102.25 multiplied by H by 2, that is 4.5. So WR can be calculated. So now let us calculate. WR will be gamma R, that is 22 multiplied by 7 meter length into height will be 9 meter into L by 2, that is 3.5. This is 4851. 4851 kilonewton meter. This is the moment. Resisting moment, this is called MR. And this is called overturning moment, this is called MO. Divided by 240.57 into 3 plus 102.25 into 4.5 bracket closed, 4.1. So this is greater than 2. Okay. Now bearing capacity failure also you will have to check it. So sometimes the ground is weak, this foundation soil or foundation bed. What is the bearing capacity? Safe bearing capacity, you can calculate it from using Terzaghi's or Meyerhoff or basic, any formula you can use it to find out the safe bearing capacity, and the value of phi is same as the backfill, and gamma is also same, 18 and 30. So you can safely calculate this. Now if you want to calculate, friends, the value against bearing capacity failure, so third check will be check for bearing capacity of the foundation bed. So here, first of all, calculate the bearing pressure due to the loading. So loading is already there. This is the wall you have created, and therefore you should calculate the bearing pressure, the eccentricity E. What will be the eccentricity E? That's quite simple. This will be equal to overturning moment divided by WR, that is the weight, plus the surcharge which is acting multiplied by L. Now overturning moment is already here. Overturning moment is already here. So The value of eccentricity can be easily calculated. WR is also known to you. So what is the value of WR? 22 multiplied by 7 multiplied by 9, 1386. This is 1386 kilonewton. And WR is there. Q is already known, L is known. What is the MO? Overturning moment is 240.57 multiplied by 3 plus 102.25 multiplied by 4.5. So this gives you overturning moment as 1181. So 1181.83 kilonewton meter. Overturning moment. WR is 1386 plus Q is 34.43 multiplied by 7 meter. Length of the geogrid. So let's calculate this. So divided by 1386 plus 34.43 multiplied by 7 bracket closed 0.72. This should be less than L by 6. So it's already okay. Eccentricity should be less than L by 6. L is 7, so 7 by 6. Eccentricity is only 0.72 meter. So now you can very well check for the bearing pressure, calculate it, and the factor of safety for bearing capacity failure will be QS divided by what is the bearing pressure. So bearing pressure, you can calculate it very easily, and the ratio, and it should be greater than 3. So with this, we have completely solved this design problem of Arival. I will take one more problem in my next video so as to make the point crystal clear. Approach will be different. So friends, I hope you have understood in totality the design of RE walls. Wish you all the best. Thank you very much.